Welcome back. We are now beginning a module on the programmable data plane. This short module will have two lessons. In the first lesson, we'll explore a particular piece of software called Click that allows the programmer to customize data plane operations. In the second lesson, we will talk about various projects underway to make the data plane more programmable and scalable, both in software and in hardware. This module has an optional programming assignment and a quiz on the concepts. Let's quickly review what a conventional data plane looks like. Before we talk about customizing the data plane, let's quickly review what a conventional data plane looks like. First, a router receives the packet. It examines the packet header, looking for the destination for that packet. It consults its local forwarding table to determine the next hop output interface. It then modifies the header and passes the packet to the appropriate output interface. Conventional data planes typically perform a simple lookup, such as that shown here. For example, an IP router would perform a longest prefix match. The OpenFlow switches that we have been talking about perform a match action data plane operation. What if we wanted to perform a richer set of operations in the data plane besides just a simple lookup or a simple match action operation? That would require additional customizations in the data plane. Now, to customize the data plane, we merely need to recognize that the data plane is nothing more than streaming algorithms that operate on packets. They match on some bits in the packet, and they perform a simple action, typically at the behest of the control plane. The data plane, of course, can perform a wide range of functions, including packet forwarding, but also a more sophisticated set of operations, including access control, manipulation of packet header fields, traffic monitoring, buffering, marking the packet, traffic shaping, in other words, shaping the traffic so that it does not exceed a particular rate, and deep packet inspection, in other words, looking into the payload of the packet, for example, to determine whether malware might be present. Now, performing such a sophisticated set of operations in the data plane obviously requires the ability to customize the data plane in various ways. And software presents unique opportunities for customizing the data plane. Network devices are quite diverse. They range from routers to switches to load balancers to deep packet inspection devices. Despite the diversity of these devices, it can be very difficult to add or modify the functions of these existing devices, often because the functions are implemented in hardware. In particular, even with OpenFlow switches, we see that the switches are capable of a particular match action paradigm. But that is really only one type of data plane. So we'd like to think about whether we could extend the capabilities of the existing data planes, potentially in software. The design goals for a programmable data plane are flexibility. In other words, we should be able to perform a variety of different data plane operations. It should be extensible, so that if we want to add new data plane operations, that should be fairly easy. And there should be clean interfaces between different types of data plane operations to make it easy to compose different types of data plane operations, such as forwarding, traffic shaping, and so forth. The Click modular router is one such customizable data plane implemented in software. The key building block in Click are elements. Each individual element in Click performs a unique data plane function, such as packet switching, lookup and classification, dropping, and so forth. The idea is that a developer of a customized data plane would take these click elements and snap them together into a packet processing pipeline. Here's a simple pipeline that takes packets from the ETH0 interface, counts them, and discards them. By assembling building blocks, developers can implement a variety of increasingly complex functions. Running a click configuration is quite simple. Let's just take a quick look at a configuration that takes packets from an input interface, prints them, and discards them. You can see here that the configuration is very simple. We take a source element, something that captures the packets, send it to a print element, and then send it to a discard element. To run click, we simply invoke the configuration file. Now we can see that click is printing every packet that is seen on the interface EN2. Now the examples that we have explored in this particular lecture are rather simple, but you can explore a lot more on the click homepage, which has links to both example configurations for various types of custom data plane operations, such as NAT, tunneling, IP routing, and so forth, and a link to a list of elements that perform a variety of custom data plane operations ranging from traffic generation to classification to counters and timestamps to packet modification to scheduling, shaping, and queue management. It's possible to stitch together click elements to build an entire IP router. The configuration here shows how the various existing click elements can be used to build an IP router. It's even possible to write your own elements in click and invoke them with the click configuration. So in summary, we not only need the control plane to be programmable, but the data plane should also be programmable. We have explored one way of customizing the data plane through a programmable software router called click. The example configurations that we've seen show that complex data plane functions can be performed using simple building blocks. And as it turns out, the performance that click provides is still acceptable for prototyping. Various performance experiments show that click is still about 90% as fast as the base Linux system for packet forwarding. There won't be any required click programming assignments in this course, but the module has an optional click programming assignment, and I encourage you to check that out if you're interested in learning a bit more about programmable data planes.